Okay, so we will begin, guys. Today, we are starting polynomials. So everyone's got a notes book, fresh notes book. So keep the other one that we've filled in, keep that for when it comes to the end of the semester when we're doing some exam revision. We've got everything collated, ready to work through. What we're doing in polynomials, we will start with quadratics, and we'll spend a fair bit of time doing quadratics. That's what we did right at the end of last year as your orientation from year 10 to year 11. And then we'll move later on, after we've done chapter 2, into chapter 4, where we do cubics and quartics, and we'll only spend a couple of lessons there. So we've got a checklist on the front here. Now, what I've said at the bottom there is that the grey and white banding indicates my plan for a double lesson. So for instance, today we're going to spend the whole lesson on exercise 2A.1. Tomorrow we'll spend the whole lesson on exercise 2A.2. And then next Tuesday it'll be 2A.3 and 2C together. Alright, so if it's white together, that means we'll sometimes do 2 exercises in one lesson. Also of note is where there's brackets, alright, so that's like extension, recommended extension. I can chat about them as we come across each of them in the exercise, but you'll notice quite different from our first checklist in that we don't have every question written down. I've been very precise about what skills that we do need. So let's get straight into it. We're talking about factorisation of quadratic equations. Oops, sorry. It's all fine, nothing.
Oh, sorry.
It's all right. I reckon I can access the board there. That's all fine. Alright, so I've got it written up the top there, just some of the expansions. So we have a plus b squared, we've got a take b squared. We touched on those two at the end when we were talking about expansion of circles. So my assumption is we know that, we're competent with that expansion, but we can also go back the other way in terms of factorisation. We also have the difference of two squares, a plus b times a take b, what that evaluates to. And we also have the null factor law. So 3 important things for us. Okay, today with our questions, all the processes are going to be the same. We want to move everything to one side. We want to collect all of the terms, and then we can try to solve the problem. So they're going to start off reasonably okay. So my first one here, 3x squared plus 5x is 0. So what I'm doing is I'm looking for what are the numbers, what are the values of x that make this statement true, that make 3x squared plus 5x equal to 0. So the way we're going to solve this is we're going to say what is common to both of these. So the first one I'm going to do nice and slowly, and I'm going to show you a couple of ways we can write this out. So what 3x squared means is it means 3 times x times x. Alright, that's what 3x squared is. And we have plus 5 times x. And so when we're factorising, we're looking at it and we're going, what is common to both of these terms? What is common to both of them? And we can see x is common to both of them. And so we're going to pull x out the front. So if I pull x out the front, alright, I pull it out the front, I've eliminated one of the x's, I'm going to be left with 3x. And if I've pulled it out the front, I'm going to be left with 5. Okay, so that's what factorising is, right? We're looking for something that's common to both, a factor, a product that's common to both, and we pull it out the front. Now the way you can check if you're correct is if you distribute this, x times 3x, that gives you 3x squared, x times 5 gives you 5x. So if you were to expand it, you would get what we started with initially. So factorising is the opposite of expanding, right? And then we're just going to apply the null factor law. Either x is 0 or 3x plus 5 is 0. Alright, so we've already got one of the solutions there. X is 0. And then if we solve this one, we'll take 5 from both sides. And then we'll divide both sides by positive 3. Alright, so I've got copious quantities of examples here. We will go through them all. And then it's about picking the questions that are at your skill level. So hopefully we're all okay with that. Let's move on to the next one, which is reasonably similar. We've got 4x squared plus 16x. Okay? So we could just pull x out the front. Hopefully we're looking at that and we can see that x is common, but there's also something else that's common. 4. Very good, Charles. So and the reason it's common is because one way you could write it, right, is like this. It's 4 times x plus 4 times 4 times x. All right, so you see, we could express 16x like that. And so now when I say what is common to both of these terms, well, 4's in both of them, and so is x. X is in both of them. So I'm going to pull 4x out the front. And if I pull 4x out the front, the first term is left with an x, and the second term is going to be left with a plus 4. Okay, so we can pull 4x. So we should get to a stage where we can look at it, just say, yep, 4x is the largest common factor, pull that out the front, and now let's solve it. We're going to have 4x is 0, or x plus 4 is 0. Divide both sides by 4 to get x is 0. And over here, x is minus 4. And so I said, what we're doing here is we're trying to find the value of x that makes this statement true, right? If you put 0 into this equation, you're going to have 4 times 0 plus 16 times 0. You get 0, so it makes it true. It's the solution. Okay, on to C. All right, we have 2x squared equals 3x. So this is a little bit more complex because there's something we need to do first. If we look at the process that I wrote at the top, it says, move all terms to one side. We want everything on the left-hand side, and we want a big 0 on the right-hand side. So I'm going to take away 3x from both sides. If I take 3x from both sides, I'm going to be left with this, right? 2x squared take 3x is 0. We'll factorise x. And then we'll apply the null factor rule. Okay, so that's what we call two-term factorization. Two terms because we're factorizing from two terms, right? We're pulling something out here. So if that's a skill you need to practice, if you just turn a page, I've got extra two-term factorization. There's lots of questions there that are about two-term factorization. Okay, so if that's something you're worried about, that's something we can practice there. We're going to move into what we call now, I'm going to show a few words for you here. Mnemonic, quadratic, trinomials. Alright, so I'm going to clear the board. So we'll move on to example D. We have x squared plus 11x plus 24 equals 0. Okay, so these are called monic. They're called monic because the number, like coming from the word mono, 1, the number out the front of the quadratic term is 1. Now, we should be getting to a stage where we look at this expression and we know it's a quadratic because the highest power along here is a 2. If we have the highest power is a 2, it's what we call a quadratic. If we have, let's think about what we did just last lesson. If we had something like this, 3x plus 2, last unit, what kind of equation is this?
Linear.
It's a line. Very good. It has a power of 1. Quadratic has a power of 2. You can anticipate we're going to study cubics. What kind of power do you think a cubic might have? 3, quartic, 4, and it just keeps going, right? We only look at cubics and quartics and quadratics. So. Okay, so we've got this non-monic quadratic trinomial. We want to find the solutions to this. There's lots of ways of doing it. We're going to use the cross method. So this is what we did at the end of last year, right? We were really trying to emphasize this skill. What we're looking for are two numbers that multiply together to give us x squared. All right, so that has to be x and x. And then we're looking for two numbers, this is the tricky part, two numbers that multiply together to give us 24. And when you add them together, you get 11. So I'm going to do this one nice and slowly. So let's think, what are the multiples of 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6. There's lots, right? And we need to go through when you say, if I go 1 plus 24, and that's not 11, that's 25. 2 plus 12, that's 14. 3 plus 8, that's 11. Okay? So that means they're the numbers that satisfy the product being 24 and the sum, when I add them together, is 11. So I'm going to put here 8 and 3. They're positive 8 and positive 3. And so that means I'm wrapping my brackets around like this. X plus 8 times x plus 3 is equal to 0. So if you wanted to check, you can expand that using FOIL, right? If you expand that using FOIL, you'll get exactly what we've got here. So that's the factorising, right? Once it's factorised, let's apply the null factor law. So I've got x is minus 3, right? If you were to put minus 3 into this equation, it's going to equal 0. And you can see if I put it in here, these are the same equation, they're just different ways of expressing it. This is what we call general form, and we'll emphasise that more later. This is linear factors. Okay, so let's move on to the next example then. We've got e. We have x squared plus 6x plus 8 is 0. So same deal, we're looking at multiples of 8 that are going to add to 6. So if it helps write them out, we're going to have 1 times 8, 2 times 4. Alright, now 1 plus 8 is going to be 9, so that's not our solution. 2 plus 4 is going to be positive 6. So that is our solution. So we're going to have x plus 2 and x plus 4 equals 0, and we'll apply the null factor law. Alright, so I think the tricky part here is the factorisation. Hopefully we're pretty comfortable with the later steps applying the null factor law. Okay, so we'll move on to f. We've got x squared equals 10x take 25. So our first step is always put everything on the left-hand side, right? Put all of the terms on one side. So I'm going to take away 10x to eliminate it there, and I'm going to add 25. Alright, so I've just moved both of these terms over. I'm taking away 10x, there it is, adding 25, there it is. Okay, so now we're looking for two numbers that when you multiply them, you get positive 25. But when you add them, you get negative 10. Minus 5 and minus 5, very good. So let's think about that. Let me explain that a bit. Factors of 25, 1 times 25 or 5 times 5. Alright? But we need them to add to negative 10. Okay? Because we've got this negative 10 here. So factors of 25, yep, it's that, but it's also these ones, isn't it? Minus 1 times minus 25 would give you positive 25, and minus 5 times minus 5 would give you positive 25. So you've seen, we've basically doubled, because of these negatives, the possible solutions that we need to consider. So that's where knowing the multiples helps and knowing rules around negatives helps. So minus 5 times minus 5 is going to give me positive 25. And also minus 5 plus minus 5 gives me minus 10. So that's my solution, right? It's x minus 5 and x minus 5. Now, an alternative way we can write this is x take 5 squared. And so you can apply the null factor law. You know, if we're breaking that down, we're going to square root both sides. And then add 5 to both sides. So 5 is the value that makes that true. Alright, it's like a new value. Okay, so that's F. Very good. Alright, we're getting through them. So now we're on to G. we're still doing monic quadratic trinomials because this number out the front is still a 1, isn't it? That's still a 1. So, let's have a look. We've got x times x plus 2 plus 3 times x take 1 equals 11. So this is question G. Alright, so for us to solve this, we need everything on the left-hand side and we need to collect all of the terms. So if we're going to collect everything, that means first we need to expand. We need to distribute these numbers. So let's do all of that in sort of one go. We're going to do x times x gives me x squared, and x times positive 2 gives me positive 2x. Alright, so all I've done there is expand the first bracket. On to the next bracket, 3 times x gives me positive 3x, and 3 times minus 1 gives me minus 3. And I said we want the numbers on one side and the letters on the other. So I'm going to, we want everything on the one side. I'm going to take away 11 from both sides, and that gives us the equal 0. So then we're going to look along there and we want to collect like terms. So like terms have the same power. So I've got here x squared. Are there any other x squared terms? No. That's going to be our leading term, x squared. And then I've got 2x, and I go, are there any other x terms? X to the power of 1. There is. We've got positive 2x, and we've got positive 3x. So when we combine them, if I have 2 lots of x plus 3 lots of x, 5 lots of x. Okay, we're collecting them together. We're simplifying the expression. And then I've got minus 3, and I go, are there any other numbers? Yep, here's one. Minus 3, take away 11. When I combine them, I've got minus 14. And we've maintained equality. This is amazing, right? This here is the same equation as this one here. We've just represented it in a different way. They have the same solutions. And now this is something that we can access. We know how to solve this. It's a non-monic quadratic trinomial. We're looking for 2 numbers that multiply together to give you minus 14. And when you add them together, you get positive 5. So first think about the multiples of 14. 1 times 14, 2 times 7. All right. But we need it to be negative 14. So because it multiplies to negative 14, it means one of the factors has to be negative. So I'm gonna write up all of the circumstances, and I'll show you the one that works. We can do 1 times negative 14, and we can do 2 times negative 7. Okay. Minus 1 times positive 14 gives you minus 14. But when we add those together, minus 1 plus 14, we get 13. 13 is not the number 5. That's not our solution. Okay, minus 2 times positive 7 gives you minus 14. And if we go minus 2 plus 7, positive 5. This is our solution. All right? This is our solution. We can check these others won't work. 1 plus minus 14 gives you minus 13, and 2 plus minus 7 gives you minus 5. So they're not our solutions. This is the one we want. And so I've said minus x is minus 2. We're going to have minus 2, and we've got positive 7. And then we'll apply the null factor rule. Alright, so you can see we're escalating in complexity. Hopefully we're doing alright still, but they are going to get a bit more complex. Okay, on to H. Alright, step 1, we want to put everything on one side. Alright, so we're going to add 24 to both sides. Alright. Now this is what we call a non-monic, because the number out the front is not a 1. Okay? However, we can actually simplify this a fair bit in order to find the solutions using processes we're familiar with. If you look at all of these numbers, they can all be divided by 2 evenly. Okay, they can all be divided by 2, or you can think 2 is a factor. I could pull 2 out the front. I could write this equation like this: x squared plus 8x plus 12. Alright? 2 times x squared would be 2x squared, 2 times 8x would be 16x, 2 times 12 is 24. That's a legitimate operation, that's perfectly fine. So one of the things I'm constantly saying is we do anything we want as long as we do it to both sides. Okay, we're maintaining equality. We're going to divide both sides by 2. Alright? So if I divide both sides by 2, here we've got 2 at the top and bottom, that cancels. We've got x squared plus 8x plus 12, and 0 divided by 2 is 0. Now we've simplified it to a monic. They're much easier to deal with. Okay, so we're looking for 2 numbers that multiply together to give you positive 12. And when you add them together, you get positive 8, positive 6, and positive 2. Alright, so I've said we've maintained equality. What we're saying is the solutions to this problem are the same as the solutions to this one. All of the operations we've performed, that's perfectly legitimate. And so the values of x that make this statement true are negative 6 and negative 2. Alright, we've got 2 to go. So on to I. X plus 1 on top of 4. I might move it over a bit. X plus 1 on top of 4 equals 1 on top of 2x. Okay, so because we have these denominators here, what we want to do is cross multiply the denominators. We want to try and eliminate the denominators. So what I'm going to do first is multiply both sides by 4. Okay? And why that's useful, let's just do one operation at a time. If I multiply by 4, here I've got 4 at the top, 4 at the bottom, that's going to cancel. My left-hand side is just going to be x plus 1. Alright, we've got 4 at the top, 4 at the bottom, that's cancelled. And over here I'm going to have 4 on top of 2x. Okay? Next we'll multiply by the other denominator. I'm going to multiply both sides by 2x. Alright? And we can see on the right hand side, 2x at the top, 2x at the bottom, that's cancelled. Alright, so let's write what we've got. We're going to have 2x times x plus 1 equals 4. Now we want to expand it, so we want to distribute this and then move the 4 over. So if we expand this, we'll have 2x squared plus 2x. That's the expansion. And then take away 4. Okay, now, hopefully we can see, we can cancel 2 here, all right? We can divide all of those by 2 and make it a non-monic. But I want us to start, make it a monic. Well, I want us to start dealing with non-monic, because I've only got 2 examples for us to work through. And there's quite a few questions in the textbook on them. So, here's what we can do. All right, when we're presented with a non-monic and we can't cancel this number at the front. What we're going to do is first just drop it. All right, we drop it off, x squared plus 2x. And then whatever that number is, we're going to multiply this last term by it. Okay? So if I've dropped it off here and I'm going 2 times minus 4, that's going to be minus 8. Alright? Okay, then what we're going to do is we're going to say, well, what are the answers to this one? What are the possible solutions? We want multiples. No, 2 numbers that multiply to minus 8 and they add to positive 2. If it helps, start listing them. We've got 1 times 8, 2 times 4. They're the multiples. One of them has to be negative because it multiplies to minus 8. So this is the solution, right? Minus 2 and positive 4. Minus 2 and positive 4. So we'll have x take 2 and x plus 4. Okay, and then the question is, remember, up in this step, we distributed that 2, right? Well, we sort of dropped it off, right? And so the question is, which of these can we divide by 2? All right? So this one, we can divide that by 2. And what do we get if we divide it by 2? 1. All right? And same with this one, we can divide that by 2. What do we get if we divide that by 2? 4 divided by 2 is 2. Okay, we're going through, we're finding the solutions. Let's apply the null factor law. And x take 2 equals 0. So here we've got x is 2 or x is 1. So they're the solutions that solve that equation for us. Okay, you can check, like if you put it in at any stage, you'll see that they're the answers. Okay, one more. 7x squared plus 6x equals 1. So that's one way you can do quadratic trinomials. That's one way we can do non-monoquadratic trinomials. I'm going to show you two here. 7x squared plus 6x equals 1. So this is our last problem, right? And we're starting to get pretty challenging now. So 7x squared plus 6x equals 1. First, move the 1 over. All right? That's what we want. We want everything by itself. Now, some of them have very obvious solutions. Some of them are really hard to see. So when we want to solve this, all right, we're looking for two numbers that multiply together to give us 7x squared. Now, we're quite fortunate in that 7 is a prime number. So that if we can factorise the roots, 7 and x are the only possible things we can multiply together to get 7x squared. Okay? Then looking over here, we've got minus 1. 1 is also a prime number. There's only two numbers that multiply together to give us that, and that's 1 and 1. And one of them has to be negative. All right? And so, we can, let's check both circumstances. All right? I'm saying one of these has to be negative. It's either that's the negative 1 or that's the negative 1. Okay? It's called the cross product method because we cross multiply here. All right, so let's investigate. Let's do this one first. If I do x times positive 1, I've got positive x. And if I do 7x times minus 1, I've got minus 7x. Now when I add them together, x plus negative 7x, I've got negative 6x. Okay? That's not my answer. I need a positive 6x. Let's check this one. X times minus 1 gives me minus x. 7x times 1, see how they cross multiply? Gives me positive 7x. And when I add them together, I've got positive 6x. Okay? That is what we're looking for. So this is the cross method. This is the one it wants. But then the trick is we must wrap the brackets around horizontally. We have to do it like this. So our first bracket is 7x take 1, and our second bracket is x plus 1. Alright, so that's quite tricky to factorise. We'll apply the null factor law. That's 1 on 7. Okay, so look, I think I've spoken long enough. One thing before we do get started in the exercise, okay? The exercise is pretty rough, all right? It sort of assumes that you've done a fair bit of factorisation before and just jumps straight into it, launches into it, and gets pretty complex pretty quickly. So, if there's a skill you need to practice in particular, right? Let's break it down into 3 skills. There's 2-term factorisation. there is monic quadratic trinomials, and then there is non-monic. Okay, so question 2 of the textbook is basically all non-monic quadratic trinomials. So they sort of escalate straight to that school. Question 1 does a little bit of all three. All right. So if you find you're really unsure about two-term factorisation, I've got some extra problems there just over the page, and the same with monic quadratic trinomials. All right. Don't get overwhelmed. Start with something that you can do, and then build your way up. So we're working on exercise 2A.1. I've got written down, the idea is to get question 1, 2 and 3 done. But we'll see how you go. I'll help you out. Sure, yeah.